Hello everyone. Welcome you all for this session on preparation strategy and important concepts of computer organization for the GATE exam. It is organized by ACE Engineering Academy and ACE Online. You know pretty well, ACE Engineering Academy is an experienced campaigner and it is giving the coaching and training for all the competitive examination on various platforms. You have this coaching on ACE Online, which is the pre-recorded videos, offline, where you can attend the classes, and live online classes, and as well the test series. If you make use of this experience of the institute as well as the faculty, you can definitely explore and you become successful in the examination. Let me introduce myself. I am Dr. Y. Chakraphani, faculty of ACE Engineering Academy. I have been associated with this academy for the past 20 years. So I am teaching and coaching and training the students since 2002. With my vast experience, I can tell you, if you have little bit of presence of mind, succeeding in the competitive examination is quite easy. I have seen many students who are moderate in their knowledge, their academic performance was not excellent, but such students, they have got very good rank in the GATE exam as well, they got into public sectors. The reason is, they have organized the things. Their execution was perfect and due to that, they got the fruits. So with my experience, I can tell you, if you are really planning for getting a very good rank in the GATE exam, otherwise all competitive examination, you need to have proper dedication and hard working. I'll come to that one by one. So in this today's session, I'm going to tell about what is the syllabus for the computer organization. You know pretty well, the computer organization is introduced recently into the GATE syllabus 2 years back. So this computer organization has replaced the microprocessor. Of course, for instrumentation students, microprocessor subject is there as it is, but for ECE and EEE students, the microprocessor is replaced by computer organization. If you learn this computer organization, it will be very useful across all the competitive examination. Why? Because it gives the global view of the computer. It is very important as well. If you follow it systematically, this is very easy also. Only thing is, you need to have proper vision what you want to achieve. Now, before I get into some of the typical concepts which are important for your GATE examination, let me tell you what is the syllabus of this one. So the GATE syllabus for 2023 consists of these 4 parts. So machine instructions, ALU and data path, control unit, instruction pipelining. He has given it in a brief manner, but in order to gain the knowledge on these 4 topics, these are the topics we need to study. Like what is the computer arithmetic, and then memory organization, instruction format, addressing modes, then you come to the ALU data path, control unit, instruction pipelining. If you look at them first time, they look scary, but actually the concepts are very simple. In computer organization, you would have observed the question will be very lengthy. You will have some 8 lines of question, but solution will come with very quickly within 3 or 4 lines. If you have the concept, you can achieve that. So computer organization at the beginning looks like scary, but once you understand the concept, it will be very easy. Okay, right. If you look at the marks, as of now, of course, we are getting less number of marks from computer organization in the GATE exam. So in 2021, we got 2 marks question based on the stack operation in the GATE exam for EC students, and 2022 we got 3 marks. It's not that many, but the thing is, every mark is going to be crucial, especially the questions which others did not answer. If you are able to answer, then your rank will be very good. So that's what you need to aim always for, okay? And coming to triple E students, so the questions were not that many. We got 1 mark question in 2021 and 2 marks question in 2022. But who knows, in the coming years, much importance will be given to this computer organization, and all of a sudden, more number of questions may come. You must be ready to handle them. As I told you, the fundamentals are not that difficult, okay, because it is made very brief. Only thing is, you have to understand them in a very quick manner and a complete, thorough manner you have to understand. Fine. What are the tips to succeed in this GATE examination, or in fact any other competitive examination? First thing understand is, I'll tell point wise, understand the needs of the GATE exam. Please try to understand, all competitive examinations are not going to be same. Different competitive exams will focus on different things. Some competitive exams will focus on the problem solving ability of the student. Some exams will focus on the conventional answering of the question, okay? In some of the exams, they will focus it. In some of the exams, both will be important, conventional as well as problem solving ability. So you need to understand what I require first of all to succeed in this examination. You know pretty well, GATE exam, requires the problem solving ability. Forget about your fundamentals. No one is going to test it, okay? Then if you solve the problem, that is well and good. But unfortunately, to solve the problems without any errors, we require strong fundamentals. So indirectly is checking, do you have the fundamentals with you or not? So that is what you need to focus it. GATE is a problem-oriented competitive exam. So it is going to test you how much depth you have in the fundamentals. The problem in GATE exam is, if you have the correct logic, we can get the correct answer. And if you do not know the fundamentals well, there is every chance that you pick the wrong answer, which looks like a right one at that point of time. So it is very confusing and you need to be very cautious with that. Point number 2, you have to explore the syllabus. So as soon as you aim at conquering the GATE exam, then you have to understand first of all, what are the needs of the exam, then you have to go for exploring the syllabus. What syllabus he has given, how you can discriminate, what are the different contents required, what subjects are required. So those things first of all you need to explore, okay? Because in some of the competitive examination, some extra subjects he will ask you, okay? So similarly in the GATE exam, what subjects you need to study, including the numerical ability as well as mathematics, that you need to go through it once. Next one is organize the subjects. Means, as I told you, you need to prepare all the subjects. Please do not leave any subject. The reason is, 1 mark getting in that particular subject is going to fetch you lot of applause. So that's the reason you need to organize all the subjects. That means how to prepare. Which subjects you need to prepare first, which subjects you need to prepare second, which subjects you need to prepare last. That's what you need to plan it, okay? But my advice is, don't keep reading only one subject every time. So I advise you, try to study 2 or 3 subjects simultaneously. So that is going to make your brain sharper, okay? So if you keep reading only one subject, things looks like very simple, but after some time you will forget. You must know the switching from one subject to other subject. Why? Because in the GATE exam, while you are answering, you need to switch from one subject to other subject, as well one topic to other topic. So that we need to practice it at the time of preparation itself. So you need to organize these subjects. Next, plan the timetable. See, the problem here is, we cannot make the timetable universal. The reason is, different students have different approach. Which subjects to study? It depends on the individual student. How to prepare the timetable? It depends on the individual timetable. Of course, if you approach us, then depending on your strengths and weakness, we are going to advise you how to prepare the subjects and how to prepare the timetable. How to prepare the notes of the subject as well the short notes, formulae, everything will tell you. But I cannot generalize, unfortunately. The reason is it will differ from person to person. But most of the times I suggest you start your preparation with network theory as well as another subject. And in that fashion, you complete digital and analog circuits. Once the digital part is over, then only you have to come to computer organization. Without the digital basics, computer organization you cannot understand. So this sequence we need to maintain. Of course, if you want still thorough guidance on this topic, you mail us, we definitely reply to them. Next one is, as the GATE is problem-oriented exam, I advise you try to solve as many problems as possible. See, there are two types of fundamentals are there. Some fundamentals you can learn it from the textbook by reading it number of times. But some of the fundamentals perception you do not understand if you look into the textbook. You read 100 times, you don't understand it. But if you go through a problem involving that fundamental, then you can understand what exactly the fundamental is referring to. So it is a very, very good resource to make you understand what exactly the fundamental is aiming for. So once you are able to solve the problem, I can say that you understood the fundamentals very well. If not, there is something lacking. Okay? So that means you are able to do straightforward formula-based questions, but if it is twisted, you are not able to solve it. The reason behind that is you did not understand the fundamentals well. So my suggestion is you try to practice as many problems as possible, any subject. So in computer organization also, you try to gather the questions from our ACE material, my notes, the competitive examination questions, all of them you collect it and try to solve them. That is going to tell you in what standard you are. Don't worry if you are not able to get the solution for some problems. Now you go back to the theory and then you revise it. So that is the way of preparation which is suitable for competitive examination. If you keep on reading the sequentially all the subjects, then it's never going to end. You always feel that something is missing. So in order to get rid of that problem, you read once, try to solve the problem, and then if you get a doubt, go back to the basics and revise. So that is going to give the overall perception in a very strong manner. This is the point number 5. And point number 6, take up as many tests as possible. Okay? So naturally, once you prepare, how do you assess yourself? Isn't it? Because the problems have become familiar to you, you are able to solve it very quickly. Then how do you assess, okay, where you are? For that, the best thing is the ACE Engineering Academy is conducting online test series. You try to register for them and try to answer to those questions given in the test series exam. There are many advantages appearing for test series. Number 1, of course, first thing, you understand try to solve the problems, number 1. Number 2, very important thing is, you try to understand the problem, what exactly logically it is given and what solution is asking for. It's not a simple one. Because I have seen many students, in spite of knowing the solution, they could not understand the question and they came out without answering that. So my suggestion is, if you write the test series exams, you will start reading the question, understanding the question. So that is the second advantage. Coming to the third one, time management. So within 3 hours, how to answer these 65 questions, out of which 55 are from technical. So that is going to be a very important one. The reason is, at home, I cannot put a timer and start solving it. It's going to go here and there. So the best way is, write the examination so that you can understand within that stipulated time of 3 hours, are you successful in answering these 65 questions or not. If it is not possible, then you have to understand the speed has to be increased. Then you can plan it accordingly. So without writing the test series, you cannot understand this. And one more feature you have it in ACE Engineering Academy is you can know your national ranking. So once you write this online test series, your marks will be given, and also what is your rank also will be given. So with that you will understand at which level you are standing as of now and what are the things you need to improve upon. I think that is the best way to practice it. So without missing, you prepare and appear for all online test series exams conducted by ACE Engineering Academy. And last but not the least, you have to be motivated, because in my career I have seen many students come with a lot of vigor, they start preparation, they go ahead with that, and after some time they lose the interest. Maybe they fall behind in the syllabus, or some of the topics they did not understand, or some other reason they are going to fall behind and they lose the interest, in the exam. So do not do that. You need to be always motivated. Even though there are some dips in your preparation, there are some hiccups, don't worry, you just start afresh and try to complete the syllabus in an effective manner. So that's a very important thing. If you are being motivated throughout your preparation, definitely you will succeed it. So if you follow these 7 points properly, I'm very sure you are going to succeed in the GATE examination and you are going to get very good score. Well, so now I'm going to tell you what are the important concepts in this particular computer organization. As I told you, computer organization looks like very vast one, but problem solving is very simple. So I have taken for each topic some typical questions. We'll see about it. Then you can feel how easy it is if you know the fundamentals. Right. Before I get into this, a quick recap of what exactly meaning of computer organization and computer architecture. This is the abstraction levels of any computer. So this is your instruction set architecture. And above part we call it as software, and the below part we call it as hardware. And this is the interface between the software and hardware. This is called the abstraction levels of a computer. So this particular one, hardware, we call it as computer organization, and instruction set architecture plus this computer hardware together, we call it as computer architecture. That's it. So what is the meaning, duty of computer architecture is, it deals with functional aspects and logical behavior of this. Functional behavior and logical aspects of this of the computer. It is the interface between software and hardware. That is the computer architecture. Look, it is the interface between the machine and the software. So this is meaning of. It also includes instruction format, that is addressing modes, what are the types of instructions, everything will come in this. What is the computer organization? As you have seen, this hardware, whatever you are using for executing the specifications of the architecture, this is called computer organization. It's purely electronics, like the circuit design, above that digital design. Using digital design, I will have central processing unit, the different types of memories, input-output systems. So these three parts together, we call it as the computer organization. So the definition is, it is the set of functional units, hardware components, which are interconnected to meet the specifications of the computer. So definitely, depending on how you design it, the system performance will be improved. The system performance improved. Yes. So it focuses to improve the performance of the system. That is called as your computer organization. Good. In this one, as I said, one of the things you should understand is computer arithmetic. So two questions we can expect on this. One is on floating point numbers, other one is on Booth's algorithm. Well, what is a floating point number is, whichever number you can't represent in integer format, we are going to go into the floating point representation. So depending on the radix point, in this floating point, we can increase the range, also we can increase the precision. So depending on where I am going to keep that radix point, if it is binary system, that is called binary point. If it is a decimal system, the radix point is called decimal point. So based on that, we can increase the range, we can also increase the accuracy. Fine. So in this one, important one I feel is IEEE 754 representation, which follows the implicit normalization, Okay, this is a single precision one, 1 plus 8 plus 23, totally 32 bits it is using. Sign, this is for biased exponent, this is for mantissa. Mantissa is also called significant. This exponent will be in the form of biased exponent. So we are going to store it in the form of XS127 format. Remember, the value of this, looking at all these bits, can be computed by using this one. Minus 1 to the power of s into 1.m into 2 power e minus 127. So keep this e value, this is the e value, keep it into this place, and this is the mantissa, keep it into this place, and this is the hidden bit. This is called hidden bit, so it is not visible anywhere, but this is a hidden bit. And this sign bit, you keep it to the minus 1 to the power of s. Meaning, if it is 1, minus 1 to the power of 1, it's a negative number. If it is 0, it is a positive number. So like this, we have to represent the IEEE 754 single precision floating point format. But remember, this biased exponent, it can have the values only from 1 to 254. So for floating point numbers, the valid values for biased exponent is 1 to 254. Reason? 0 and 255, they are used for special numbers. Okay. Yeah. If you look at this, finally, the representation of floating point numbers, this is the minimum value you can represent, and this is the maximum value. We have discussed already the procedures to find these values. Okay. So 1 into 2 power minus 126, and here 2 minus 2 power minus 23 into 2 power plus 127. So this value is this. And this maximum value is this. How it is? Please go through the literature. Okay, right. You know that this is called positive and negative overflow, and this is called as positive and negative underflow. Okay, so that's what you can understand it. Fine. As I told you, the exponent values of 0 and 255, they are reserved for special number representation. Look at this. If it is 1 to 254, there is no problem. It is any value of mantissa, it represents a floating point number. But 255 and 0, it represents infinite number. If exponent is 255 and not equal to 0, it is not a number. If exponent is 0 and mantissa is not equal to 0, this is called denormalized form. Meaning of denormalized form means it is smaller than the smallest value it can represent. Yes, look at this. If my input is here, it cannot be represented in IEEE 754 single precision format. That's the reason these numbers from 0 to this place, they will be called as denormalized form. Meaning it is the value, analog value, which is smaller than the minimum value that can be represented. So that's the reason whenever you get this type of numbers, it will be shown as exponent is 0, mantissa is not equal to 0. Of course, if E is 0, mantissa is 0, this is going to represent plus 0 or minus 0. That's it. You may ask me, sir, what is the meaning of not a number? Some examples I have given here. Log minus 1 is not known. Square root of minus 1 is not a number. Infinity minus infinity, so on and so forth. All these things, they are not going to give the numerical result. That's the reason we call it as not a number. So the advantage of this IEEE 754 representation is Apart from representing floating point numbers, it will also represents +0, -0, denormalized number, infinity, not a number. So all these things are going to be represented. That's the reason it is an efficient representation. Okay, so this is represent 10 in IEEE 754 single precision format. So you know that you have to write it in proper form, find the mantissa, find the exponent, find the biased exponent, and then get the result. So I quickly do this in this fashion. Ten can be written as 1010 binary. And after normalization, this can be written as 1.010 into 2 power 3. This is the hidden bit. So that means this I need not show it anywhere. Okay, this is the hidden bit. Then this is your mantissa. And this is the true exponent E. This is the true exponent E. So then the biased exponent is equal to the true exponent plus 127. That is equal to 3 plus 127 equal to 130. Yeah, so by now we know the mantissa and we know what is the biased exponent in terms of decimal. So write it in terms of binary, it is 128 plus 2. Yeah, 128 plus 2, it's going to become 130, that's it. So this is nothing but your biased exponent in terms of 8 bits. So take all of them and put it into this format. Yeah. As it is a positive number, put it as 0. And then biased exponent is this. And then mantissa in terms of 23 bits is this. Yes. So now I would like to convert this into hexadecimal. This is 4, this is 1, this is 2. So look at this, how simple it is if you know the basics. If you want to represent the decimal number in this particular format, this is the final value. So in 41200000H, 8 hexadecimal digits. Okay, so that's how we can answer to this. Next. Similarly, if you ask it reverse, find the decimal value of the floating point number 40A00000H. Okay, so this is the given number. You know that this symbol stands for hexadecimal. Okay, so 0 hexadecimal 40A0 like this. So I have written it in terms of totally 32 bits. 32 bits. From this we need to understand different things like this. So this is the biased exponent. This is the sign bit. This one is mantissa. That's it. Okay, so this is the sign bit, biased exponent, and this is mantissa. Now let's find out quickly what the solution for this. Exponent, biased exponent in terms of decimal is 10000001 stands for 129 decimal. Thus, the true exponent is biased exponent minus bias, 127. That is 129 minus 127, it is equal to 2. So, okay, and then this is the mantissa. Okay, so mantissa is equal to 1.010. So then its value is given by it's like this. Minus 1 to the power of s multiplied by 1.m multiplied by 2 to the power of true exponent. So this will give the value quickly for this. That is minus 1 to the power of 0 into 1 point. What is the mantissa? 0, 1, 0. And then multiplied by 2 power 2. That's it. So this is going to become plus 1.01 binary will become 1.25. 1.25 multiplied by 4. So this is going to become 5 decimal. That's it. Finally, 1.25 in terms of decimal multiplied by 4, it is going to be 5. So the standard of the questions most of the times in computer organization will be like this only. Okay, right. Fine. Right. So he is telling in the format of the single precision floating point representation of a real number as per the is as follows. Okay. The format of the single precision floating point representation of a real number as per the is as follows. Which one of the following choice is correct with respect to the smallest normalized positive number? Smallest normalized positive number. So positive number means the sign bit should be 0. Exponent minimum value is 1. And mantissa, it can be all zeros. That's it. So the smallest value we can have is sign bit is 0. Of course, it's a positive number. Exponent value should be from 1 to 254. Minimum is 1, maximum 254. So this is 1. Mantissa can be zeros. That's it. So the correct answer to this is C. Exponent is 1, mantissa is all zeros. So if you know the concept, it's quite 1 second solution. Right. Next one, you know the Booth's algorithm. What is the advantage of Booth's algorithm is it is meant for multiplication of signed numbers in 2's complement form. Multiplication of signed numbers in 2's complement form. And you know that multiplicand and multiplier, both of them can be signed numbers. Multiplicand can be a signed number, multiplier also can be signed number in 2's complement form. And for that, we are going to use this Booth's algorithm. Okay. If multiplier is given like this, then what is the Booth's code for this is, we will start with assuming a 0 here. Based on this, we'll come to know how many number of additions and subtractions we are going to do it. For example, 0 minus 1, it is going to be equal to minus 1. So this is called Q0 and this is called Q minus 1. So we are going to say that like this. If it is 0, 1, that means, if it is 1, 0, that means we are going to perform A will be equal to A minus M and arithmetic shift right of A, Q and Q minus 1. Yeah, look at this. Whenever you are getting this value of minus 1 or else whenever Q0 and Q minus 1 values are 1 and 0, that means this operation you need to perform. Okay, next one, 1 minus 0. 1 minus 0, it is equal to 1. So it says that if Q0 and Q minus is equal to 0, 1, then operation is going to be like this. So whenever these values are, two successive values are 0 and 1, then you have to perform this operation. After that, you have to go for arithmetic shift right. What is the meaning of arithmetic shifting? It will protect the sign bit. it will protect the sign bit. So arithmetic shift right of this register, Q register and Q minus 1 bit, that you have to do it. In the similar fashion, if Q0 Q minus 1 is equal to 0 0 or 1 1, then no addition operation to take place, no subtraction, simply you have to arithmetic shift right. This is very simple. So these are the three things we need to understand. So here I am performing subtraction. Here I am performing addition. But here there is no addition or no subtraction. How many such subtractions and additions you want to perform? To know that, we will find out the Booth's code as I did here. 0 minus 0 is 0. 0 minus 1 is minus 1. 1 minus 1 is 0. 1 minus 0 is 1. 0 minus 1 is minus 1. So as you can see here, the number of subtractions to be performed are 2. So the number of subtractions to be performed is 2. And the number of additions to be performed is 2. That's it. So in this manner, we'll come to know for this given multiplier, how many additions, how many subtractions we require. Okay. Probably you know the rule also. Number of subtractions in this Booth's multiplication will be equal to the number of additions or 1 greater than the number of additions. If number of additions are 2, then the number of subtractions will be either 2 or 3. If number of additions are 4, then the number of subtractions will be either 4 or 5. So that is what you need to understand. Okay. In this example, for this multiplier, number of additions and number of subtractions, both of them are same. Okay. So there is no place where number of additions will dominate the number of subtractions. That never going to happen. Yeah, I think this is the flowchart for that, whatever I told here. So these are the 2 bits we are going to observe. You can see, if it is 1 0, that means perform the subtraction. Okay, accumulator minus some BR register, put it back into accumulator. If it is 0 1, perform addition. And if it is 0 0 or 1 1, do not perform any arithmetic operation, straight away come here. This is nothing but arithmetic shift right of accumulator as well as QR register. And after that, the sequence counter will be decremented. You need to know how many times I have to perform this operation. It depends on the number of bits in multiplier. If multiplier is 8-bit multiplier, we have to perform this operation 8 times. Then it's going to complete the process. So it's a very effective operation for any Booth's multiplication. Okay? But if my multiplier is in the form of 0 1 0 1 0 1 0 1 or 1 0 1 0 1 0 1 0, at that time Booth's multiplication is ineffective. It is as bad as normal multiplication. Okay, so try to understand. If your multiplier Q, if it is having a form of 1 0 1 0 1 0 1 0, or else if it is having a form of 0 1 0 1 0 1 0 1, in these cases the Booth's multiplication procedure is ineffective. Yes, so a few questions on memory. You know that there is byte addressable memory as well as the word addressable memory. What is the meaning of byte addressable memory? Means each byte we can access it. What is the meaning of word addressable memory? We can access only one word at a time. First of all, let me tell you, byte is 8 bits always, but word, it is not a constant value. It can be 8-bit, word can be 16 bits, word can be 32 bits, word can be 64 bits. It depends on the type of CPU. Okay, so now if this is 4096 into 16, what does it mean? It is having 4096 memory locations, and in each location it is able to store 16 bits, which is nothing but one word. So how many number of bits I require to select one location out of 4096? So you can access only one word. So in this case, word is equal to 16 bits. Word is equal to 16 bits. So 4096 locations are there, and each location, one word has been stored here. So then how many number of address lines we require? 2 power n should be greater than or equal to 4096. That is 2 power n should be greater than or equal to 2 power 12. That is n equal to 12 address lines. So for this memory internal access, it requires 12 address lines. So this is 12. Okay. So now, if you want to access it each byte addressable memory, how many address lines it requires? 12 address lines in order to select one word, and in that location 2 bytes are there. Okay, it's going to be like this. So 12 address lines in order to select one memory location, and in each location 2 bytes are there. To select 1 byte out of 2 bytes, one more bit we require. So that you can write it in this fashion. For example, 2 power 12 into 16 is equal to 2 power x multiplied by 8. So this is going to give it here 8 twos are. So this is going to become 2 power x is equal to 2 power 13. So x is 13. So number of bits required is equal to 13. Okay. So like this one, if you equate, then I will come to know how many address lines are required for byte addressable memory. It's not difficult, you just need to understand. Okay. I think I've given the solutions for the next one in the similar fashion. If it is word addressable, okay, in this one, what is the size of the word? 64. Size of the word is 64. In this one, the size of the word is 32 bits. So if it is word addressable, to select one location out of 512, 9 bits are required. But if you want to go for memory, byte addressable memory, it requires 12 bits. How do we do that? 512 into 64 is equal to 2 power x into 8. If you equate, then you will come to know this. Yeah. So another very interesting question came in the GATE exam is this. The numerical value of a 2-byte unsigned integer on a little Endian computer is 255 more than that on a big Endian computer. Which of the following choice represents the unsigned integer on a little Endian computer? So he's telling that the numbers, for example, a 16-bit number. This is the 16-bit number. Okay. It is stored into a memory in the big Endian form, and it is stored in the memory in little Endian form. Value on a little Endian computer is more than the value on a big Endian computer. How much more? 255. Then, which of the following little Endian one, it's going to show the correct answer. Okay. So first one, if you say that how the numbers are stored, let me put it like this. In little Endian, this is big Endian. So the Endian is nothing but the method of storing the multi-byte number. Okay, method of storing the multi-byte number. Okay, look at this. Yeah. So for example, this is on little Endian computer. Okay, this is stored as, this is hexadecimal 6665. And if we store it into big Endian computer, these 2 bytes will be shuffled. So this will become 6566. Okay, next one. 0001. And here it shuffle this. In big Endian, we are going to store it like this. What's the meaning of big Endian? Means the higher byte at higher address and lower byte at lower address. Nothing but simple. If you know the little endian format, if you shuffle the bytes, you get the big endian format. Okay, next one. Yeah, 42, 43. And here it becomes 43, 42. Last, 0, 1, 0, 0. And this is 0, 0, 0, 1. That's it. So now I gave an idea. If these numbers are on little endian looking it like this, on big endian it looks like this. He's saying that value on little endian should be 255 more than value on big endian. So this cannot be the answer. Why? Because on little endian its value is small, 0, 0, 0, 1, smaller than 0, 1, 0, 0. So the B cannot be the answer. Similarly, this value is smaller than this, so this cannot be the answer. So the answer has to be either A or D, that's it. So what you have to do? Subtract this value from this one. Yeah, we can do this subtraction directly in hexadecimal itself. 6 cannot be subtracted from 5, hence you get a borrow. This becomes 15 hexadecimal and this becomes 5. 15 is 21. 21 minus 6 in decimal, 15, that stands for F. Okay, again, get a borrow from here. If I get a borrow here from here, this is going to become 15 and this is going to become 5. So 15H is nothing but 21 decimal. So 21 minus 6 is 15, that is F, 0, 0. So A is correct. Why? Because the difference between little endian and big endian value is equal to FF, which is 255. Similarly, the second one. These are hexadecimal, okay? Hexadecimal, same. 1 cannot be subtracted from 0, so get a borrow. It is going to become 10H, which is equal to 16 decimal. So 16 minus 1 is 15, which is equal to F. Similarly, get a borrow from here. This becomes 10H, that is equal to 16 decimal. Here it is having a pending 1. Here it is having a pending 1 because from nothing we have given a borrow. So this is pending 1. So 16 minus 1, it is going to become 15, which is F. This is 0, this is 0. That's it. So what you say about this is the correct answer to this one is A as well as D. So that is the meaning of little endian, big endian techniques, and then if problem is given in this fashion, how to handle it. Look at this. Concepts are not difficult, but only thing is little bit effort is required to understand them. Yeah. Instruction format. So you know that the instructions are classified into 3 address instructions, 2 address instructions, 1 address instruction, and 0 address instructions, as well RISC type of instruction. Okay. So we consider what is the problem given here. The instruction length is 8 bits and it is having 8 registers. That means so depending on the number of registers, the number of bits per each register is going to differ. Okay, quickly, this is going to be decided as 3 bits per register as there are 8 registers are there. Okay, next. It supports opcode expanding. If it has 3 2-address instructions and 2 1-address instructions, find the 0-address instructions. Okay, so next point, it is having this is 3 2-address instructions. Yeah, this one is of course opcode, leave it, opcode, and the total length of this instruction is, he told that it is 8 bits, 8 bits, and then such type of instructions are there, 3 of them. Address 1, it is going to be shown with how many bits? 3 bits, because address is nothing but the operand. This is 3 bits, that's it. So it's going to have 3 multiplied by 2 power 3 into 2 power 3. That many number of combinations will come. Okay, similarly, next one. One address instruction. Yeah. So he's telling that address 1 will take up 3 bits, and such type of one address instructions are there. How many of them are there? It is having 2 one address instructions. Then how many number of 0 address instructions are there? So 0 address instruction will contain only opcode. Okay. So how many such type of instructions are there? It's very simple. Using 8 bits, how many combinations are possible? That's equal to number of combinations for 2 address instructions plus number of combinations for 1 address instruction plus number of combinations for 0 address instructions. So that is, I'm going to say like this, 2 power 8. So using 8 bits, this is the total number of combinations of the instructions you can have it. Then 3 2 address instructions. So this can take 2 power 3 combinations. This can take 2 power 3 combinations for registers. That's the reason this is the answer. Next, 2 one address instruction. One address, only one address, 2 power 3 plus n into 2 power 0, because it doesn't have any address. That's it. So this is going to become, okay, you can take, this is 2 power 3, 2 power 4 common. If you take 2 power 4, 2 power 4 is equal to 2 power 2 plus 1 plus n. That is 16 minus 12 minus 1 is equal to n. So n is equal to 3. So that's it. Conclusion is it has 3 0 address instructions. I think if we just take up this universal principle, we can get to this answer of such questions very quickly. Okay, right. Yeah. So here I just try to find out what is the effective address. Okay, forget about all the things. It is having effective address. See, if you look at this one, this is going to be register indirect addressing mode. It is register indirect addressing mode. So that means the value from the memory comes into R5 register, and the address of that memory is given by R1 plus R2 plus 70. That is called effective address. So in this problem, the solution is effective address is equal to R1 value plus R2 value plus 70. What is the meaning of effective address? It is the address of the operand. Effective address means it is that's it. Okay. So this is going to come in this fashion. R1 is given as 300. R2 is given as 1200. And 70 is as it is. That's it. This is going to give effective address is 1570. That is how you need to work it out. Yes. Okay. It is a question on relative addressing mode. It is a question on relative addressing mode. So it's telling that after going for this conditional jump instruction, it has to jump from here to this place. This is the target address. He has given this. Okay, so this is the target address. I think in the next page it is there. Yeah, now it's missing. Okay, so it has to go from here to here. If that's the case, what is this offset value we need to mention? Remember, the program counter, it would have incremented to this place by the time this instruction is fetched into the CPU. That's the reason its latest value is equal to I plus 4. So it has to go back from here to here 4 places, 1, 2, 3, 4. Means I minus I plus 4, which is equal to minus 4. But each instruction is how many bytes? Each instruction is having totally 4 bytes. That's the reason 4 instruction means 4 into 4, 16 bytes negatively you have to go. Yeah, is as simple as this. Okay. So look at this, all the problems are simple. We need to understand the basics properly. Looks like a very lengthy one, but solution is very simple, matter of 2 steps. Okay. Yeah, this is matching, of course. Base addressing, we always use it for this particular position independent. Okay, so that is called as, you can relocate. Okay, for relocating the program, base addressing mode is useful. So that's the reason A, the correct match is yes. Next, for B. Yes, B, indexed addressing, it's meant for array. Next, C, stack addressing, it is meant for re-entrancy, that is A, P. Okay, so you can enter into the stack memory number of times. Okay, that's the meaning of it. Next, implied addressing, it is meant for accumulator. That's it. So this is the correct answer to this one here. A, S, B, R, C, Q, C, P and D, Q. The answer is A. So these are the typical properties of each addressing mode. If you apply them, you can get to the answer. Yeah. CPU basics. So one just quick example, I have already worked out and given the solution, but let me ask you first as a problem. There is one program, the program is same. Program I have written, for example, a high level language program has been written. It is executed on processor P1, also it is executed on processor P2. And the cycle time for this processor is 1 nanosecond. And here the cycle time is 0.7414 nanoseconds. Means processor 2 is faster in terms of processor 1. This frequency of operation is high compared to this. Next, for this program, this particular processor 1, it has converted into 10,000 instructions. But unfortunately, the compiler used here, it converted the program A into instruction count of 12,000, more number of instructions. That's the reason you have to use a compiler which is very efficient. Next, this is branch instructions, load and store instructions, ALU instructions. It is 20, 40, 40%. And here these instructions are 25, 50, 50, 25. And then the cycles per instruction is in this ratio, And here the cycles per instruction is in this ratio. Then which processor is better? Program A executed on processor 1 or program A executed on processor 2? Which one is the better one? Okay. For this to compare, we have to find out its execution time. You know that formula for execution time is equal to instruction count multiplied by average CPI multiplied by the cycle time. This I will represent this as tau. Yeah. Based on this, I am going to tell you which processor is better for executing the program A. Okay. Look at this. So first, I am calculating average CPI for the first processor P1. It has come as 2.4. What are the units for this? 2.4 cycles per instruction. And then execution time is computed, and this much of time it requires. That is nothing but 24 microseconds. Similarly, for processor 2, with the given ratios, the CPI will come in this fashion. That is going to be 3.125 cycles per instruction. Okay, it requires that many cycles per instruction. So what is the execution time? It's going to come like this, which is equal to 26.775 microseconds. That's it. So what is the conclusion? The time, okay, it is better to execute your program A on processor 1 compared to processor 2, in spite of the clock frequency of processor 2 is more. In spite of having the more clock frequency, better to execute on processor A because it is better in other parameters and its execution time is less. Yes. Similarly, the ALU and data path. You know that all arithmetic and logical operations are performed in ALU. What is the meaning of data path? It is the collection of functional units. Collection of functional units like ALUs, multipliers, buses, registers. Those collection we call it as data path for a particular computation. That is called as ALU and data path. Okay. Right. So many a times he is going to give the data path like this. Okay, these are the registers R0, R1, R2, like this it will continue. If you look at this data path, you can see that it is having single bus, many number of registers and one arithmetic logic unit. But one thing here is, if you want to perform any addition, those inputs must be available in S register and T register. Only after getting that values into this, it will perform the addition. Okay. So then he is asking how many clock cycles it requires to perform this process. How many clock cycles for executing this particular process? Okay, it's very simple. Look at this. First, you have to get R0 into this S register. Next, get the R1 into the T register. After that, it will compute that addition of these two registers. As ALU is a combinational circuit, do not count the time taken for this. Do not count the time. Next, once this output is available, this should be written back into R0. This should be written back into R0. So to perform this operation, it requires 3 cycles. Yes. So I'll put it here like this. Okay, in the T0 cycle, S register is going to receive R0. Similarly, T register will receive R1 in the T1 cycle. After that, the R0 is going to be receiving the value coming out of ALU addition. That's it. So these are the 3 clock cycles it requires. You may ask me, sir, what about the time taken by ALU for addition? I told you, do not include the time taken by any combination circuit, because that will be taken care while you are finding out and fixing the cycle time. Okay, that's it. So this is going to go here. In the similar fashion, the memory is going to require 2 access. If that is the case, how many number of clock cycles it requires? It's not machine cycles, it is clock cycles. Okay, for memory access, 2 of them, 2. To write this into this one of them. Because PC plus 1, it is already executed in fetch cycle. He is asking how many number of clock cycles you require during the execution cycle. Please understand, any instruction cycle will consist of two parts. One is fetch cycle, other one is called execution cycle. In the fetch cycle, the CPU fetches the instruction from memory and decodes it. And in the execution cycle, that instruction is executed. In this question, he is asking about only execution cycle. In this execution cycle, how many times CPU goes to memory? Okay, that's what he is asking here. So how many clock cycles it requires to perform this operation? To write, okay, this PC plus 1 increment, it is happened in fetch cycle. So don't count this time. So write this value into Rn, this is one cycle, T0. Next. For going to this, and getting the value from memory, it requires two things. First thing is, into memory address register, store the value of PC. And then, looking at the data path, we need to write this. From MDR, put the value into instruction register. That's it. So this is 3 cycles. Okay, this is meant for memory. And finally, that value should be written into PC. So in the T3 cycle, PC is going to receive the value from instruction register. Okay, so like this, the number of machine cycles required, clock cycles required is equal to 4. So in this manner, understand it and find out easy asking the number of cycles in execution cycle or in fetch cycle or in instruction cycle. Based on that, you can answer to this. Yeah, so control unit, you can design it in the form of hardwired control unit. For example, these are the control signals, S1 to S10, and these are the instructions. This is the different time intervals. So if I ask you, what is the meaning of hardwired control unit? Means it is a logic circuit implemented using AND OR logic, which will implement an SOP expression. For example, the expression for S5, suppose S5. Wherever S5 is there, you round it off. Yeah, that's it. So S5 requires at all these instants of time for different instructions. So then, what is the expression for S5 control signal? Is equal to T1 multiplied by I1 plus I2 plus I3 plus I4. As it is required in all the instructions, for all the instructions it required, I will write it as simply T1. I don't mention for which instruction it is. Next, it requires S5 for I2 instruction in T3 stage, for I4 instruction in T3 stage. Hence, I will write it as T3 multiplied by I2 plus I4. That's it. So this type of circuit we are going to use to implement S5. Yeah. So like this, the SOP expression is obtained and it is implemented using this logic, and you can generate this control signal. Okay, that's quite easy in the case of hardwired control unit. This is another one using JK flip-flop. Yeah, if you go for the microprogrammed control unit, you know that it is having totally 4 types. Horizontal microprogramming, vertical microprogramming, hybrid microprogramming, and nano programming. Okay, he is asking what are the features of vertical microprogramming, micro instruction. So you know that it is going to have high degree of encoding. So in the vertical micro instruction, we are going to store the control signals in the form of encoded form. It is going to be stored in the form of encoded form. That's the reason it is one thing. Next, it is going to have limited parallelism. So I cannot get all the control signals simultaneously. In fact, only one control signal you can obtain. Only one control signal. So I can say that the more opt answer is this one. Even limited parallelism is also not there. You will get only one control signal at a time. That's the reason no parallelism. So answer is B for this. Yeah. Which of the following is correct in the case of horizontal microprogramming? You know that horizontal microprogramming, it stands for generating all the control signals at a time. Yeah, that's it. So what is the feature of this is all control signals can be generated simultaneously. So which one is correct in this one? First thing, the decoders are not required. What is the reason? Control signals are stored in the form of true form, not in encoded form. Once it is not in encoded form, we don't require a decoder. Next, it results in smaller sized micro instructions than vertical microprogramming. Wrong. Because as the control signals are put in true form, its length will be more. Next, it is going to have high level of concurrency. Yes. Why? Because it will generate all the control signals at a time if required. And then efficient use of control memory. Wrong. Why? Because even for one control signal, I need to waste this entire micro instruction. Suppose it is having 128 control signals. In one cycle, I need to generate only C0 control signal. Still, I need to waste that remaining 127 bits. That's the reason its efficient use is not there. So answer correct is A as well as C. Like this, if you understand a few basic things, then you can easily get into this. You know that what is the meaning of pipelining? A sequential process will be divided into number of sub-process separated by registers or latches. These are the latches and these are the segments or sub-process. And each sub-process is executed in a separate segment. Each sub-process is executed separate segment. Due to that, the performance is going to increase. Okay, right. What type of performance? The throughput is going to increase. The meaning of throughput is number of instructions executed per second is going to increase. So that is the advantage with pipeline. And then the operations of all the segments is synchronized by using a clock input. By using a clock input to the latches, its operations are synchronized. And remember, the speed of the pipeline is dictated by the slowest segment of this pipeline. That means whichever segment is slow, based on that only we can decide what is the frequency of operation. Okay, right. So you know that this can be represented in this form, which is called as space-time diagram. So in the first clock cycle, instruction fetch is filled with I1 instruction. Okay, you can take this as I. This is instruction or task. Whatever you want, you can take it. If you are getting confused, we can take like this. So each instruction will enter one by one. Yes. So instruction 1 is in instruction fetch segment. Then after some time, it will move to instruction decoding segment. While it is in instruction decoding segment, instruction fetch is vacant, hence instruction 2 will enter here. These two will move forward, then instruction 3 will enter here. So into this, one by one instruction will enter into the segments. That means when instruction 1 is in the last segment, instruction 2 will be here, instruction 3 will be here, instruction 4 will be here, instruction 5 will be here. So this is called space-time diagram. Yeah, so these are the formulae, standard ones. We have discussed it thoroughly. Speed up ratio, throughput, as well as your pipeline efficiency. Please go through these expressions once. Yeah, this is important. If you take a single instruction on a pipelined CPU with time T2 taken on a non-pipelined but identical CPU, sorry, T2 is taken on a non-pipelined but identical CPU, we can say that which is the relation. Always remember, for one instruction, non-pipelined processor is better compared to pipeline because there are no latches in the case of non-pipelined processor. So for one instruction, non-pipelined one is better compared to pipelined one. So that's the reason. What is the correct answer? T1 is the time taken for single instruction on a pipelined basis and T2 on a non-pipelined. So the answer is T1 will be greater than T2. T1 will be greater than T2. Okay, so for one instruction, pipelined processor takes more time compared to non-pipelined processor. So like this, you can go through all these problems and I have solved it. Okay, so later you can go through this one. And finally, to conclude this, RISC processor, reduced instruction set computer processor. So it is having the features different from CISC architecture. Okay, right. So what is the main thing you have to understand here is, in RISC-1, instruction size is fixed, execution time is fixed, it takes only one clock cycle. We have seen in instruction pipelining, and then main operands are registers, and you can use memory access only with two instructions, either load or store. That's it, nothing else. And then instruction format, it is going to be fixed one. It is going to be a fixed one. Whereas if you come to CISC processor, instruction size is variable, time taken you cannot tell exactly, some instructions takes only one cycle, some instructions takes more cycle. And then instruction operands, it can be register or it can be memory. Okay, so that's the reason it's going to have complex. And then memory access, we have multiple ways, and then instruction format is variable. Okay, you are having something like different types of instructions you are having it. It doesn't have a fixed format. Okay, so that is about the RISC processor and CISC processor. Yeah, so you can go through this one. Same thing, I have put some more points here. RISC is going to emphasize on software, whereas CISC will emphasize on hardware. Suppose I want to have a multiplication. This, they prefer to write it in software, but in this one, they prefer to have a multiplying unit. They want to have a multiplying unit in that. Okay. Of course, for any instruction, it takes only one clock cycle, but it takes multiple. And here, pipelining implementation is easy. What's the reason? Instruction format is fixed. Once I have the fixed instruction format, pipelining becomes simple. But here, instruction pipelining becomes difficult, little pipelining is there. And then less number of instructions, so few addressing modes. So instructions are less, automatically addressing modes are less. More number of instructions, more addressing modes. And importantly, this will use hardwired control unit, but this will use microprogrammed control unit. So one plus point here is, any RISC processor will have large number of registers, plenty of them. Why? Because the memory access is restricted, so it will have more number of registers. Because of these registers, it has the concept called as overlapped register window. Overlapped register window. Because of this, the procedure calls is going to become very speedy. It won't take much time, unlike your CISC processor. Okay, that means one register will be common for the calling program and called program. Okay, it will be common for both. Because of that, I need not pass the parameters. Okay, I need not pass the parameters to the procedures. Due to that, its speed is going to increase. So this is called ORW. And that is not possible here because number of registers are less. Okay, here it is possible because the number of registers are more. Okay, so this is the complete outline you can understand about the computer organization. Yeah, which of the following statement is true or true? RISC is faster than CISC, true. RISC is costlier than CISC, no. RISC has a load store architecture, yes. CISC has overlapped register window concept during function call, no. That's it. The correct answer is A and C. Why? Overlapped register window concept, it is there in RISC processor. Okay. Yeah, that's it. So after going through the notes given by faculty, we have very beautiful material for this computer organization in different forms. Please try to go through this one here. So this is volume 1 for electronics and telecommunications. It is going to contain all the chapters and all the subjects, so which includes the computer organization. And this is for your ESA examination. So computer organization, the booklet is going to be in this fashion. Okay. So you can go through for getting more number of problems. And this is for GATE as well as ESA exams as well as for public sector exams, computer organization and architecture. So you can see here, theory is given very brief manner and very effective manner, and as well there are so many worked out examples and some practice questions. I'm sure if you can understand these problems given here, as well as if you are able to solve these practice questions, I'm pretty surely I can say that you are very good at computer organization. So as I said at the beginning, if you want to succeed in the GATE examination, please remember you need a smart work, okay, not the hard work. Okay, you need to have the knack, what you need to study, what not to study, how to apply the principle and which principles I need not apply. So many things, it's a combination of so many things. Finally, in the exam hall, with all these inputs, you maintain your composure and try to answer as many questions as possible, so that will fetch you very good score. So I wish you best of luck in all your future endeavors. Thank you.
My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy and if you will work hard, you will definitely achieve your goal. Thank you. My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy and if you will work hard, you will definitely achieve your goal. Thank you. My name is Gaurav Kumar. I have secured All India Rank 1 in GATE 22 in Electrical Engineering. I was enrolled in ACE Academy offline coaching. The ACE Academy really helped me develop a strong basic required for GATE exam. I was also enrolled in ACE Academy online test series. The questions in ACE Academy online test series were very good and helped me develop a strong temperament required for the exam. My tips for the future aspirants who are preparing for GATE exam will be that you should have a very clear plan and strategy, like how you have to approach the exam, and also believe in yourself and do hard work, because if you have a very good plan and clear strategy and if you will work hard, you will definitely achieve your goal. Thank you.